Of course, we can take our phases and change them into one another, right? We can turn a solid into a liquid and a liquid into a gas. And the way that we do that is we either add or take away energy, right? So as we add energy into the system, it can go into overcoming these intermolecular forces, right? So if we take, for example, go from left to right, we're going to increase the amount of kinetic energy we have. Right, as a solid, we've got these intermolecular forces, and these intermolecular forces are keeping these molecules together and then keeping them from moving apart from one another, right? So they're keeping them in place. If we add some more energy, we then become a liquid. And while our intermolecular forces are still strong enough to keep our particles together, we now have enough kinetic energy to move the molecules around. And then finally, if we add in enough energy, we become a gas. And in this case, we've totally overcome or we've broken our intermolecular forces. And here's like kind of the same picture just out of your textbook, much better illustrated, right? As you add more energy, you go from being a solid to a liquid to a gas, right? And so how much energy you have to add to the system to turn it into a solid liquid gas depends on the strength of these intermolecular forces. The stronger these intermolecular forces, the more energy it's going to be required to break them. And so you need a higher temperature to do so, and that results in them having higher melting and boiling points, right? So the stronger intermolecular forces you have, the higher these physical properties are. So for example, propane is C3H8, and it has relatively weak intermolecular forces. While on the other hand, water, H2O, has relatively strong intermolecular forces. And then for propane, that's this thing you grill with, right? So it generally comes as a gas at room temperature, and that's because its melting and boiling point are very low. Its melting point is negative 188 degrees Celsius, and its boiling point is negative 42 degrees Celsius. While water, we have a melting and a boiling point of 0 and 100. And that's due to water's stronger intermolecular forces. And these intermolecular forces are similar to our, kind of protons and neutrons in that we have the rule that opposites attract. Right, so these intermolecular forces are also attractions between positive and negative charges or partial positive and partial negative charges.